I'm going to talk about adding, subtracting, multiplying, and dividing in this video, and watch the second video for composition. But all of these are called operations of functions, or algebra functions. So what is a function? A function is a relationship between a set of inputs, those are your x values, and outputs, those are your y values, where each input is used only once. So any kind of function, as long as your x values are only used once, then you're good to go. Notation is to use f of x instead of a y. So we're going to talk about operations of functions. So that means you can add, subtract, multiply, and divide functions. Here's the notation. I know it looks a little funny, but f plus g of x can also be written as f of x plus g of x. And this makes it a little clearer of what's happening. You're taking your f function and your g function and you're just adding them together or combining like terms. This is probably the notation you'll see on tests and in textbooks, but this is also acceptable notation. Make sure you realize this is, I'm taking my f function and adding my g function to it. I'm just going to leave a generic x in the problem. I'm not multiplying by x or doing anything extra. I'm just leaving an x in the problem instead of plugging in a specific number. Okay, so that's adding. Subtracting is similar. It's f minus g of x, so leave your generic x in the problem, or you can rewrite it as f of x minus g of x. And you subtract each piece, each term of your g function from f, and then combine like terms. To multiply, it usually is just written fg of x, or sometimes you see the little dot in the middle. But this is f of x times g of x. And you're just going to FOIL or double distribution and then combine like terms. So you're going to combine like terms in all of these. Except the last one is f slash g, or f divided by g of x, which is written f of x over g of x. And this one's the easiest one, or most straightforward. Don't overthink it. Literally, you just write it as a fraction and you don't have to do anything else. Okay, so let's practice some examples with all of these: adding, subtracting, multiplying, and dividing. So example number 1, let's let f of x equal x squared minus 1 and g of x equal 2x plus 5. So part A, let's first figure out what f plus g of x is. That's the notation you'll see. It may help you to write it f of x plus g of x. So we're going to take our f of x function, this x squared minus 1, and we're going to add our g of x function to it. All you have to do here is combine like terms. So this is my only x squared piece. This is my only piece with just an x in it. And then these two are constant whole numbers, so I can combine like terms or add them together. -1 plus 5 is 4. And we're done. That's all. If you're going to subtract, it's a slightly different problem. So this is the notation, f minus g of x. So that's the same thing as taking f of x and subtracting g of x from it. So you take your f of x function, but you subtract each piece of g. So I'm going to subtract my 2x and subtract my 5. So reminder, subtract each piece, each term of g of x. And then combine like terms. So this again is my only x squared term. Again, this is my only term with an x in it. And then I can add my two constant whole numbers together. They're on the same side of the equal sign, so just add them together. So -1 plus -5 is -6. Okay, so straightforward, those are just adding and subtracting. Let's do one if I asked you to add, but if I gave you a specific number I wanted you to plug in. So what if you had something like f plus g of 2? This is f of 2 plus g of 2. So you have two options here, and this is always going to be the case. So first, you can figure out what your generic f plus g of x is and plug into that equation. Or you can plug into f, you can plug into g, and then you can add your answers together. So two options. Our first option is sub 2 into f plus g of x, which was found in part A. So since we already found that, it might be that's a fast way to do it. So part A, our answer was x squared plus 2x plus 4. So I'm going to plug in a 2 squared plus 2 times 2 plus 4, and multiply in your head, use a calculator, whatever you need to. 4 plus 4 plus 4 is 12. Or if you don't already know what f plus g of x is, sometimes that's the long route, and it's easier to just sub 2 into f and sub 2 into g and then add together. So you kind of do it in pieces. So if I plug a 2 into f, f is x squared minus 1. So 2 squared minus 1, 4 minus 1 is 3. If I plug a 2 into g, 2 times 2 plus 5, g was 2x plus 5. That is 4 plus 5 is 9, and now 3 plus 9 is 12. So either way, you get the same answer, your choice, whatever you want to do. But just know if I ask you to plug in specific numbers, you can always find the generic equation and sub in there, or sub into each piece separately, and then whatever your operation is. If you're adding, add them. If you're subtracting, subtract them. If you're dividing, divide them. There we go. All right, let's do multiplying and dividing too. So same two equations. We're going to just continue this. This would be part D. Let's do fg of x. This can also be written f of x times g of x. So you take your f of x function and your g of x function, and you're going to just multiply it all together, or FOIL it all together. So distribute your x squared to both pieces. X squared times 2x is 2x cubed. X squared times 5 is 5x squared. And distribute your negative 1. So negative 1 times 2x is negative 2x. Negative 1 times 5 is negative 5. If you have like terms, usually these middle two terms are like, and you can add them together, but since they have different exponents, that's all you can do. So we FOILed, and then combine like terms if possible. In this case, it's not possible because I don't have like terms. And we're done. And finally, let's do division. So if I was going to divide these, f divided by g, you literally take your f function and write it over your g function, and you don't have to do any more work than that. Technically, if you could factor and cancel, you should try and factor and cancel. We can factor the top to x plus 1 and x minus 1, but it's not going to cancel with anything in the bottom, and generally that doesn't happen in these examples, so you can stop there. Okay, so I'm done with this example. So we've done one straightforward with polynomials, adding, subtracting, multiplying, and dividing. Let's talk about this rule real quick, and then we'll come back to that. Don't distribute into a square root, a log, absolute value, but you can distribute to a square root, a log, and an absolute value. And I know that sounds picky, like it doesn't make sense because it's the same thing. But let's do an example so you can see what I mean. So we'll add, subtract, multiply, and divide here. All right, so let's add first. F plus g of x is the same thing as f of x plus g of x. So take your f of x function and add your g of x function. When you add, all you have to do is combine like terms. In this case, I don't have like terms. This is an x, this is a number, and this is a square root. It's considered one whole term in itself. So even though, yeah, I have multiple x's, This x is part of a square root, so I can't combine it with anything. So I don't have like terms, so I'm done. That was quick. Subtracting f minus g of x, remember that's taking your f of x function and subtracting your g of x function. You subtract each piece of g, but the square root itself is just considered one piece. So I'm not going to distribute my negative into my square root. I'm not going to change these signs underneath my square root. Instead, I'm just subtracting the whole square root as a whole, and combining like terms. So that's what I mean. Don't distribute the negative into the square root. Into or under the square root. It's all considered one term, so I'm just saying x plus 2 minus the square root. Done. But I can distribute to a square root, and that makes more sense if you see when we're multiplying. So if I multiply, I'm going to have x plus 2 times my square root. I can distribute my x to the square root and distribute my 2 to the square root. So I have x times square root plus 2 times square root. And I hope you realize that I've just been saying square root and not square root x minus 1, because I'm trying to reinforce the square root is the term. I don't care as much what's underneath it. It's just square root is the one piece by itself. So here's what I meant. Don't distribute underneath the square root, but I can distribute to or out front the square root, out front of. So I can distribute an x in front and a 2 in front, but I can't distribute the x inside here to make it an x squared minus x or a 2x minus 2. Don't do any of that. So that's what I meant. Same thing for logs. You wouldn't distribute a negative into the parentheses of your logarithm, and you wouldn't distribute into an absolute value symbol. Okay, and then last, let's do division, and then we need to talk about domain, and then we'll be finished with this video, but I will also have a composition video for you. Okay, so f divided by g of x means f of x over g of x, so you put your f function over your g function, and you don't have to rationalize it. We're done. Call it a day. Okay, so that's all adding, subtracting, multiplying, and dividing. You can now figure out the domains of all of these different equations. So remember, for domain, refresher, we have to set our square roots greater than or equal to 0, our log or natural logs greater than 0, and your denominators, yeah, you can't see that, not equal to 0. So just like before, we're going to use those same rules. So in example 1, A, I don't have a square root, I don't have a log, I don't have a denominator, so that's my domain. Same thing for part B. That's boring. Same thing for part D. Now I finally have a denominator that I set not equal to 0. So now my domain actually gets interesting, and it is negative infinity to negative 5 halves, union negative 5 halves to infinity. So rules don't change. If I have a denominator, deal with that. Same thing here. In example A, I have a square root, so I have to set it greater than or equal to 0. So x is greater than or equal to 1. So there's my domain. Same thing, I have a square root, x is greater than or equal to 1. Same thing, I have two square roots, but they happen to be the same thing, so set them greater than or equal to 0. And then here, when I'm dividing, I have a denominator and I have a square root. So square root we already figured out. X has to be greater than or equal to 1, but denominator, my square root can't equal 0. If I square both sides, 0 squared is still 0. So x can't actually equal 1. So when you do your domain, negative infinity to infinity, you shade to the right of 1, but you have to have a big open circle here because it can't equal 1. So they actually only overlap right past 1. So that would be parentheses 1 to infinity. Okay, so anyhow, those rules don't change. The only time this happens is every now and then you have a special problem where this square root gets canceled out, or whatever you originally had gets canceled out. So if an operation cancels out a square root, a log, or a denominator, then you have to go back and look at the original equations to figure out your domain. Otherwise, just look at what we did straightforward. Just look at your answers. Just look at these equations to find things. I started with a square root, and I still had a square root when I did my operations, so I didn't have to worry. But this shouldn't happen very often, but I wanted to show you one example. If I had f of x is 1 plus square root x and g of x is square root of x, if I was going to subtract these two, I'd have f of x minus g of x, and when I combined like terms here, both of these are square root of x that I can add together. Well, they add up to 0. So this would be my answer. So you think just looking at this answer that my domain is all real numbers because I don't have a square root, I don't have a log, and I don't have a denominator. But I originally had a square root. So I need to go back and look at the original problems because it got canceled out and my domain has to follow the original equations. If that's confusing, don't worry, it won't happen very often except maybe a problem or two on homework. I don't want to try and trick you. Just use your original equations to come up with your domain. I mean your final answers, and just like normal, come up with your domain.